Hi everyone, welcome to the PCD for today's Codeforces round, that is Goodbye 2024. I am Pradyumn Kejriwal and this is TLE Eliminators. So let's get on to our first problem. Today we'll discuss the first five problems. Okay, so the first problem is this. So I'll read it. This is just time pass. Uh, the problem says that Kokoli is given an array A1 to AN. Master calls a set of integers as stable if and only if for any possible UV and W from the set S. Note that UV and W do not have to be pairwise distinct. Sticks of length UV and W can form a non-degenerate triangle. So what does this mean? That a set S is called stable if we can choose three integers from that set, any three integers, they can repeat as well. And for any such three integers, they have to satisfy that they can form a triangle. That is, they have to satisfy the triangle inequality, right? So then Kokoli is asked to partition the array into several non-empty contiguous subsegments, such that for each of the subsegments, the set containing all the elements in it is stable. Master wants Kokoli to partition A in at least two different ways. You have to help him determine whether it is possible. So yeah, that is the problem. I'll just explain the problem again. The problem is basically we have been given an array A. Let's say A1, A2, up to AN. We have been given. And we have to partition it. Let's say this is the array. So we have to partition it. Essentially, we have to add walls in this and make the partitions. So this is one partition, this is one partition, this is one partition, and this is one partition. And from each partition, we make a set. Like from this partition, we make a set S. From this one also, we make another set S. Or let's say S2, this is S1. And we make these sets. These sets are the sets of integers that are in this position. If there is 4 and 5 here, then this set 1 contains 4, 5. That's the meaning. And basically, we have to ensure that all sets are stable. And what does stability mean? That for any three integers, A, B, and C, in the set S, the triangle inequality should be satisfied. Basically, the smaller, let's say A and B are the smallest. C is greater than A and B, then A plus B should be greater than C. This is the condition for triangle inequality, right? So for every set S, satisfy hona chahiye. And basically, we have to determine whether there are at least two ways of doing this or not. Like the partitioning, if there are at least two ways, then we have to print yes, else we have to print no. And there is one thing, let's say, actually I got a bit confused during the contest that let's say the set is 3, 4, 5, right? So is it we have to, initially I assume that we have to pick three integers, 3, 4, and 5. We cannot pick 3, 3, and 3. But that I was incorrect. That's one mistake that you could have done. You can take 3, 3, and 3. So basically, this is also a valid side length from this set. So what I am saying is, now let's think about when can a set be stable, right? Let's say we have the set S. Let's say it is 3, 4, 5, 6, 7. So guys, tell me that is it stable? Is it stable, this set? It is stable. No, it is not stable because you can take 3 and 3 from here and 7. Basically, you can take 3, 3, and 7, and this can't make a triangle, right? right? So whoever said yes, do they understand that why it isn't stable? Yeah, so it is not stable. So basically, after seeing this, can you all tell me that when will a set be stable? Like given a set of integers, when will it be stable? Can you tell me that? I think it is pretty easy. Yes, minimum into 2 is less than or equal to maximum. Great. So in the set S, if y is the minimum, like, all right, I'll just explain that the intuition behind this. Like basically we have some set, let's say we have this one only. So what is the corner, like what is the extreme case? Like when we have to ensure that a plus b is greater than or greater than c, right? So what is the case when this will not satisfy? Like basically I have to try and not satisfy this, so I will take ab as the minimum and c as the maximum, so that maybe it will not satisfy. So if I take 3 and 3, it will not satisfy this inequality, right? So that's why it is not stable. So basically what we want is that minimum, like if I take a as the minimum and b as the minimum, minimum plus minimum should be greater than maximum. I'm taking c as the maximum. Like this is the extreme case. If this satisfies, then definitely other pairs will also satisfy. So that's why, like this is the condition for a set to be stable. All right. Now one more thing. Observation here is that, like, I read the samples explanation. Like let's say um, in the second sample, it is given that Kokoli can partition each element as single subsegment. Like in this array, he can partition it like this, and this. So from that, I got this idea that I can partition the array into singular numbers, like always. Like it is always possible that, let's say I have an array a1, a2 up to an, then I can always partition it into the singular sets. It is always possible because in that case the minimum would be like just ai. For set I, the minimum would be ai and maximum would be ai. So definitely 2 into ai is greater than ai. Our condition is 2 into min should be greater than max. So our condition will definitely satisfy, right? So this is one arrangement of doing. But we want to find out whether there exists at least two or not. So basically we just want one more and then we'll be done. Right? Now guys, can you do you agree that the smaller the set is, the more its probability to be stable? Like if a set is bigger, then definitely it has more chances that it is not stable. Or more formally, let's say a set S is stable, then every subset of S, that is T, is also stable. That's what I'm saying. Like if set S is stable, then if you choose any numbers from this and put it into T, then definitely this will be stable or not. This will be always be stable. So basically we want the set to be small, right? So this is array and we'll partition it, right? So one partition we have already checked out that this is possible always. Now we have to find another one that is not this one. So what can be the other one? Like in the best case, it can be like we are selecting just two, and this is one partition, and the rest of them I am just um, partitioning like differently. Like all of these are singular, and this is like this set is two of them. They are combined. So this is the best thing. Like if this is not possible, then definitely no other partition is possible because you get it right. We just want the set to be small. So even if the smallest is not possible, then definitely a bigger set would not be possible, right? So I'll just check whether this can happen or not. Like basically, I have this array. Let's say I have uh, 3, 4, 7, 9, and 8. So first, I'll check whether these two are compatible or not. Like if I keep them in same set, then will they satisfy? So yes, they will satisfy because minimum is 3. So 3 into 2 is greater than 4. So therefore, I have achieved one partition, which is not like singular one. I can partition it like this, right? So this is the partition that I can do. So the answer is yes in this case. But let's say I have an array like 8, 3, 9, 27. So this is the array. So first we'll check these two. Can we put these two in same set? No, we can't because 3 into 2 is less than 8. Then we'll check these two. We can't put these two in the set also because 3 into 2 is less than 9. And then we'll check these two. But this also we can't put in a set. So definitely any two adjacent elements we are not able to put. So there's only one way to make the sets, right? There's only one way. That is we can just do singular elements. So in this case, the answer is no, right? So I think the it should be clear. Like this is the algorithm that will just check the adjacent elements. That does any one pair satisfy that 2 into min is greater than max? Like if there is any one pair satisfies this condition, then our answer is yes. Else our answer is no. Got it? So any problems, any doubts, anyone? But the question was at least two partitions. Here there are four partitions. No. Like the question asks that you have at least two ways to partition. Two ways means um basically this is one way, right? This is just one way that we have singular, like we divide the array into singular things. This is one way. What could be the other way? The other, like, it is not valid, but the other way is something like 8927, right? So the other way is something like I just put the barriers here and here. So this one way is different from this way. So these are the two ways. But definitely this one is not valid because they don't satisfy. But my point is that you have to tell them whether there are two distinct ways of partitioning. They aren't asking about how many sets there are after the partition. Okay? Anyone? Can you explain again why checking two elements is sufficient? Because let's say a set has A, B, and C. Let's say a set has three elements, right? So let's say the minimum is A and the maximum is C. So definitely, if this is satisfying, like this is stable, right? If this is stable, then we know that 2 into A is greater than C. Now, if you take any subset of that, then definitely, like here the minimum is A, right? Minimum is A, and the maximum is C for this, right? Now, if you take a subset of this, then do you agree that the minimum can always increase? Like either it can stay the same A or it can increase because if I remove this A, then it will increase, but it can never decrease. Do you agree this? Yes, and the maximum can always only decrease. So if in this case, if 2A greater than C satisfies, Then after, then let's say we take a subset of this, then A would increase or C would decrease. So they are favorable conditions. Like in that case, this will still satisfy because A is increasing. Yeah, okay, got it. Okay, let's explain the fourth test case. Wait, fourth test case is this and this. So this is yes because you can, like, one way to partition is, we have, let's say I'll just take 10 10 instead of whatever this is, 1 lakh 1 lakh. I'll just take 10 10. This is the array. So one way to partition it is like this, just two individual. And another way is 10 10, and like the whole array is one partition. So there are two ways. Therefore, the answer is yes. Got it? Or do you have a problem with this? Uh, he is not replying, so I am assuming he got it. Okay, anyways, so let's see the code. It is straightforward actually. So yeah, this is the code. I just took the input like n, c in n, input the array. This is my macro, and this is my for loop which runs from 0 to n minus 2. Like n minus 1 is inclusive, so I'm exclusive. So this for loop runs from 0 to n minus 2, like I is less than n minus 1, right? Then I will just check if 2 into minimum of, like I'm checking ai and ai plus 1, like can they form a set? So I'm checking that their minimum into 2 should be greater than maximum. If that is the case, then they satisfy and we can put them together. So I'll just print yes and then I'll return. Like this is the case. And if I have not, if this doesn't happen, if this never happens, then I'll just print no. Okay. Any problem with this? Clear. All right. So I think we can move on to the problem B. Yeah. Right. So problem B is like Eric still remembers n pieces of impressions in the form of an integer array. He records them as W1 up to W1. So we have an array W1 to W1. However, he has a poor memory. So for each I to n, he can only remember that Li, like Wi is between Li and Ri. Okay. Eric believes that the impression I is unique if and only if it is unique. If and only if there exists a possible array such that Wi is not equal to Wj for all j. Like basically, in a certain array, element I is unique if and only if there is no other element with the same value as I. So like if such an array exists, then element I is unique. So please help Eric determine whether an impression I is unique for every 1 to n independently for each I. So the problem is like, um, we have been given an array. Actually, haven't been given an array. We have just been given like ranges. We have been given n ranges Li to Ri. Like, um, this is, let's say, 7, n equals to 7. Then we have been given a range for this element, that this element can be from, let's say, 1 to 3. Then this element can be from somewhere 2 to 4, let's say. Then etc. Like this is what we have been given, right? And for each element, we have to print something. What do we have to print? I'll explain. Let's say for this element, we are printing the answer. Let's say for this element, we are finding the answer. So what we have to say is that, does there exist an array such that this element is different from all the other elements. This is the problem, right? So I just explain some sample test cases. Let's take this one, 13131313. So basically, we have four elements, and all four of them can range from 1 to 3. So let's say for this element, I want to say that can it be unique? Then yes, it can be unique because I can just set this one to 1 and the all of these to, let's say, 2 or let's say 3. So in this array, like all of these elements are in the range. They have to be in 1 to 3, right? All four of the elements have to be in this range of 1 comma 3. So they are, and this element is unique. So therefore, there exists an array such that this element is unique. Then similarly for this element, in this array it is not unique, but we can make an array in which it is unique. Let's say we make 2, 1, 2, 2. So in this array, this element is unique, right? So that's why the answer for this element as well is yes. Like we have to print yes or no for each element, or basically 1 or 0 for each element, and we have to print a binary string of length n. That is, for each element we have to either print 1 or 0. So in this case, it will be yes for all of them. That is, the answer would be 1 1 1 1. Yes, right? Okay. So what is the intuition here? So the intuition is that you have some intervals, right? Now, actually, I thought that when would the answer be no? So I just checked the test cases. Let's say I saw the third one, right? So the third one is this 362212113422, and I saw that for element number 2, the answer is no. So I wondered, why is it no? I checked out why is it no. So it is no because the element has range 2, so it can only be 2. But there's another element that is 6, which can also only be 2. So that's one problem, because both of them have to be 2, so that's why they can't be unique. So therefore, for the element 2 and 6, the answer is no, right? But the answer for 3 is also no for some reason. So let's check why. 3 can be between 1 and 2. 3 can be between 1 and 2. But the thing is that 4 has to be 1 and 6 has to be 2. So therefore, either 4 or 6, either one of these will coincide with 3. Like if 3 is 2, then it will be same as this element. And if the third element is 1, then it is the same as the fourth element. So do you get this, guys? Or should I explain on the whiteboard? Clear. So yes, what I saw is in this case, the answer is no. In what case? Like basically, let's say I'm checking for element I, right? So it has some Li and it has some Ri. So the answer is no if all the elements from Li to Ri are taken. What am I taken? That, let's say this is the range. We have Li and Li, and we have Ri, and there are some numbers between these. So let's say each one of them has been taken. Now, what I mean by taken is that let's take numbers for better understanding. Let's say this is 5, 6, 7, 8, 9, 10, 11. So this is 11. So this is different. This is like 7, right? So let's say that this is index I. Now, if I am at index I, then let's say there's an index j, which is 7, 7. Then definitely 7 is taken. So our ith index cannot be 7 because 7 is taken, because jth one is 7 always. So this can't be there. Now let's say we have one more range. There is one kth element which is 8 comma 8. Then this 8 comma 8 also taken. This is taken, right? But let's say we have some range, let's say L, which is 5 comma 6. Then what will you say, guys? Will you say that both are taken? What, like, will you say this? This is a question. I'm not saying. This is a question. No. Yes, you won't say that both are taken. Like, basically, if you want to take 5 from this, then you can just give this element 6, right? Like, you are at element I. You are checking for the element I. Then let's say you want to give this element I as 5. Then no problem. Just give this element L as 6. It doesn't care. Like, it has options. So what we are saying is that all the elements which have options are not a problem to us. They are not a problem because we can always just use some other number in that. Like, if we want to use some number and that number happens to be in the range, like here we wanted to use 5, but 5 is in this range for this L, then we can just set this L as 6. So it is no problem. Like, I just explained my example. Let's say we have this input. Uh, let's say we have just 4 numbers. This is 1 to 3. This is 2 to 5. This is 4 to 4. And this is 3 to 4. So let's say we want to calculate for this number, this element 2 to 5. So definitely we can't give 4 here because 4 will be here definitely. But let's say we want to give 3. So 3 we can give actually. Even though there is one range, actually there are two ranges which have 3 in them. 1 to 3 and 3 to 4. But that doesn't matter because they have other options. Like, this has option to give 4. We can give 4 to this one because this has an option. And we can give either 1 or 2 to this one. So definitely we can give 3 to this one. That's what I'm saying. That all of these ranges, which are not a single element, like the length, if length is greater than 1, 4 is taken in third place. Yes, but I'm just checking for this element. Like, I'm checking the answer for this one, whether the answer for this is 1 or 0. So I just have to ensure that this element is distinct from all the others. So if I want to place 3 here, I can place any element other than 3 in all the other elements. So what I am saying is all of those intervals with length greater than 1, they are of no problem to us. They don't cause a problem because they can adjust, right? So I am saying that when will no come? No will come. Let's say we were talking about 5 to 11. Right? So I'm at the ith element, which has range 5 to 11. Ith element has range 5 to 11, let's say. So when would the answer be no for this one? It would be when all the elements are taken in this range. Let's say 5, 6, 6, 7, 8, 9, 10, 11. So if all the elements from 5 to 11 have been taken, then only the answer is no. Like, what do I mean? That there is some element which is 5 to 5, like some other element which is 5 to 5, then some other element is 6 to 6, and so on. Like, all of these exist in our condition, 7 to 7. Yeah. So if all of these exist, all of these, then we have no place to put for this I. So in this range, if all are taken, then definitely we know that the answer for this would be no. And if any element is not taken, like, if let's say if 9 to 9 is not anywhere, it doesn't exist, then definitely we can say that the answer is yes, because we can choose this 9 for this I, and we can just adjust for all the other elements, because there is no element which wants only 9, right? So this is an observation. Like, this is not the complete solution. We have to check for all of the elements. So how do we do that in O of n? Actually, n is 2e5, right? So we have to do it in O of n. So how do we do it in O of n? Let's say. So for checking the element I, n log n, yeah, n log n also works. So yeah, I did in O of n actually. So I'll just tell how I did that. So let's say we want to check for element I. So let's say I has range Li to Ri. I'll just draw it on the number line. I has the range of Li to Ri. Now basically we want to check that in this range, how many elements are problematic. Like in this range, if all are taken, then definitely answer is no. Else the answer is yes. Like, and how do we do that? Basically, we can just do that. Let's say, yeah, and the elements are from 1 to 2n, right? They are from 1 to 2n. So we can use this, that we can make an array of 2n length. We can actually make an array of 2n length. This is even, right? Yeah. So let's say n is equal to 4n, this case. So we'll make the array of 2n length, and whichever elements are taken, like let's say the input is 1 1 or 2 3 5 5. Let's say this is the, or let's say 6 7. This is the input. So in that case, initially all of the elements are 0. But then I'll iterate to the input and check that this 1 1. 1 1 is a problematic because it only needs 1. So in the first position, like this is the array 1 2 3 4 5 6 7 8. This is the array. So in the first position, I will just change it to 1 because there is some element which wants this. Then 2 to 3 doesn't matter. 5 to 5, I'll change this to 1, and then 6 to 7. Let's say this is not 2 to 3. Let's say this is 3 to 6. All right. Now I have done this. Now let's say I want to check for 3 to 6. The answer. That is it yes or no? Yes or no for this 3 to 6. Then what do I check? I'll just check that in this range of 3 to 6, what is the number of ones? If that is 4, then the answer is no. And if it is not 4, then the answer is yes. Like, you just need to compute the sum of this range. And if it is equal to 4, then the answer is no, right? So now that you can do using prefix sum. Yes, you will just make this array first. You will take the prefix sum of that, and then you will just, like for each index, you will calculate the sum for each for that range, and then if that is equal to the length of that range, like in this case 3 to 6, this is the range 3 to 6. So the sum was equal to its length, that is 4. If the sum was 4, then definitely you can say that the answer is no. But there is one caveat to this. There is one mistake in this logic. Can someone tell me? When both are same, L equal to R. Yes, length one interval. Yes, yes, yes. So, like let's say if there are two elements which want that same number. In that case, the answer is no, right? Like if there are two elements, let's say the input is 1 1 and 1 1. So our algorithm would print no, anyways. Yes, if the problematic number is at the correct position already and it is the only one at that position, right? That is the condition in which our algo fails. Like I'll explain. Let's say we have this input 1 1 2 3. This is our input. Now the array would be like 1 2 3 4. So initially all of these are zeros. This is 1 1. We look at this and we make this as 1, right? Now what we do is we check for this 1 1. So we check this range and we see that the sum is equal to its length. So we just print no, right? This whole range is taken. So we print no. But that is wrong because it is taken by this 1 1 only. Like we want that. Basically, there is no other element which wants this one. So therefore, the answer should be yes, but we are printing no. So we can just mitigate that. Like what I did was actually there are many solutions to this, but what I did was that I just instead of like only saving one and zero in this array, I saved the number of elements. Like let's say I have the input something like 1 1 1 1 and 2 2. Then the n is 3, so 6 length ki array. And since 1 1 appears two times, I am storing 2, say I am storing 1, and say I am storing 0. This is one array. And in another array, what I am doing is I am just storing the ones like 1 1 0 0 0 0. Like I am making two arrays basically. And I just like this is the array in which I can count the non-zero ones. Like I'll just check the range sum for this. Like what I'm so basically, let's say we want to check for this one, right? So we will check this range L to R, or let's say 1 to 1. The sum is equal to 1. Like I'll check the sum in this prefix. मैं इसका ही लूंगा इस array का. So the sum is 1 and length is also 1. So before printing no, I will just check that in the corresponding this array, if this number is 1, then I will print yes. I'll repeat. Like basically for L equal to R wala case, I just check that if that number is 1, then I'll print yes. And if it is 2 or greater, then I'll just print no. I won't even check the sum in that case because it is just one element. So like for L equal to R wala case, I will just check this array and the sum, if that is 1, then the answer is yes. And if this like if this is 2 or greater than 2, then the answer is no. Because let's say we have this 1 1 1 1 and 2 2. So here 1 appears two times. So if I want to check for this 1 1, then the answer for this is no, right? Because there are two elements which want to appear in one. So therefore the answer is no. And yes, we can use map also for this. We can do anything. There are many ways to do this, but this is one way, right? So I hope it is clear. If it is not clear, then anyone can tell me, and I'll make it clear. I'll try to make it more clear. Okay, so if it is not, uh, if it is clear, then let's just, I'll show you the code. The code is this. So I'll just take the input, int n, int n cname. Now I'll just take the input of lr. Then I made this vector, the problematic one, like this. This is called v. Like I'm calling this one as v. So I'm making this vector like for I to m. If li equals to ri, then like this is the problematic one. Then I just increment that position. All right. Then I just take the prefix. Actually, I'm not explicitly making that array. I'm not making this array in my code, but I am making its prefix directly. I am making the prefix of this array without making this array. So as you can see that this is the prefix sum array, and p of I plus 1 equals to p of I plus a of I. So instead of a of I, I'm just adding this. Like this means that this would be 1 if it is positive, and it would be 0 if it is 0. So essentially, I'm making this array and taking the prefix sum. But I'm not actually making this array. It is just done like this. Then I'll just print the answer. Like I iterate over all the elements. Um, Actually, this implementation is very clumsy. Like it is not exactly what I have explained, but this is what was like. This is what strike to me in the contest, so I just typed it. This is not the same as what I taught, so just ignore this for now. All right. I'll share the like I'll share the new code which I explained. You can find it in the description of the YouTube video. So okay, let's just move on to the problem number C. All right. The problem says that there are n stars in the sky arranged in a row. Iris has a telescope which she uses to look at the stars. Initially, Iris observes the star in segment 1, n, and she has a lucky value of 0. Iris wants to look for this star in the middle position for the segment LR that she observes. So the following recursive procedure is used. So the following procedure is used. First, she'll calculate m. If the length is even, then Iris will divide into two equally long segments for further observation. Otherwise, Iris will aim the telescope at star m, and her lucky value will increase by m. Subsequently, if L not equal to R, then she will continue to observe two segments. Iris is a bit lazy. She defines her laziness by integer k. As the observation progresses, she will not continue to observe any segment LR with a length strictly less than k. In this case, predict her final lucky value. Okay, so the problem is something like there are some stars. So I want to draw stars, or let's just draw some stars. We have these stars, and the value of these stars is like 1 to n. 1, 2, 3, 4, 5, and 6. Now Iris observes these stars. So first she wants to observe this 1 to n, or 1 to 6. Now to do this, she basically breaks these stars into 1 to 3 and 4 to 6, right? So she breaks these into 1 to 3 and 4 to 6, and then observes them again. So in 1 to 3, the middle one is 2. So basically, she adds 2 to the answer. And she again breaks these into two different ranges, which is like 2 2 has been observed. So she breaks this into 1 and 3, right? And then she observes them again. and this range she breaks into, like, this is 4 comma 6, 4 to 6, right? So the middle element is 5. So she'll add 5 into her answer, and then she'll break this into 4 and 6, and then she'll observe the remaining ones. She'll observe this range is 1, so the middle is 1. So she'll add 1. Then in this range, the middle is 3, so she'll add 3, and like this is the thing that she is doing, plus 4 plus 6. So the answer is 21. But this is the case where she doesn't stop. Like if she keeps doing this recursive process, then eventually she will see all the stars, and the answer would just be sum up to n. Like answer would just be 1 to plus 2 up to n, which is n into n plus 1 by 2, right? But the thing is that she is a bit lazy. She is a bit lazy. So uh, once the segment size is less than k, like she has a number k, so once that segment size becomes less than k, then she stops observing the stars. Like for example, I just dry run this test case. We have n equals to 7 and k equals to 2. So we have 7 stars. 1, 2, 3, 4, 5, 6, 7. So first of all, segment is this. Now she will break it into two parts, 1 to 3 and 5 to 7. And she'll add 4 into her answer because the length is odd. So she'll add 4 into her answer. So 4 is added. Now she'll break these two segments further down, right? So she'll break it into, um, like she'll observe these also. So she'll break it into just one. She'll add 2 to the answer, and she'll break it into 3. And same for this segment, she will break it into 5. She'll add 6 to the answer and break it into 7 as well. But now the segments have size less than a k, like k was 3. So these segments have size less than k. They have one size. So therefore she will stop. She won't observe these segments. She won't observe these segments. So final answer would be this. 4 plus 2 plus 6 is equal to 12. So the answer is 12. Now for better understanding, I'll just explain second one also. The second one we have 1 to 11. So for 1 to 11, she'll observe 6, which is the middle one. So 6 is 6 at the answer. Then we have 1 to 5 and 7 to 11. So for both of these, wait, k is equal to 3. This length is 5. So she'll observe this length is 5. So she'll break it into 1 to 2 and 4 to 5 and observe the third one. So 6 plus 3, and she'll break this one into 7 plus 8 and 10 plus 11, or I mean 7 to 8 and 10 to 11. Sorry, 7 to 8 and 10 to 11, and she'll add 8 to the answer. So her answer would be 17. Wait, 18. 3, 3 plus, my bad, this is 9. So the answer is 18, right? So this is the problem. Like we have to figure out her final score. Now, guys, tell me that if I just write a function, let's say I write a function f l to r, and which takes in a k value, and if, like, basically it just does what it is told. Like the process, it just does it. Like it will just call f of l comma m comma k, and it will call f of m plus 1 comma r comma k, and it will add the answers and it will return it. And yeah, this is for even, and for odd it will do whatever. Like basically it will do what it is told. What is told, it will just do. So why wouldn't this work? Because states are very large. Yes, it will get TLE. Yeah, people get TLE. The TC of this is O of n. It is not 2 to the power n, it is just O of n. Actually, I'll explain why it is, but it will get TLE because n is up to 2e9. So, why is it O of n? Because basically, for calculating 1 to n, we are calculating first um, 1 to n by 2 and n by 2 plus 1 to n. So we are divided into two parts. Then again, we divide into two parts up till we reach like the size is 1 or k, let's say. If k is 1, then I'm talking about this case. If k is 1, then we do this process until the size reaches 1. Like all of these leaves, their size would be 1, right? So how many nodes are there? How many states are there? These are n states. These are n by 2 states. Like basically this whole tree has uh, 2n states approximately. I mean 2n minus 1 maybe. Um, like this has n, this has n by 2 and so on. So it's like approximately 2n minus 1 states. So it is O of n. If you want to calculate recursively, it would be O of n, right? So what can we do about this? So what we can actually do is, guys, let's say I tell you, observe this. We have 1 to 5. This is one range, and we have 6 to 10. Now, don't you guys think that this range is same as this range? It is just shifted by 5. This is just shifted by 5, right? So, like if we add 5 to all the numbers from this, we will get this. So, let's say in this one, let's say k equals to 2. So, in that case, what would the answer be for 1 to 5? Let's calculate that. If k equals to 2, then the answer for this would be like 3 plus, I think it would be 3 only, right? Because first of all, it would break down into 1 comma 2 and 4 comma 5 and 3 would be added. Then she would break down this into 1 and 2 and this into 4 and 5, and then she won't observe these ones because k equals to 2 and their length is just 1. So the answer for 1 comma 5 is 3. So now guys, can you tell me the answer for 6 comma 10 without calculating? 8. We just added 5 to this. Let's take another example. This was a pretty bad one actually. Let's take example of, let's say we have 1 to 6 and 7 to 12. So they are both same, just 6 is added. So let's do, and k equals to 2. So for this 1 to 6, the answer would be like it would first break into 1 to 3 and then 4 to 6. Then we would add the answer of 2. We would add the answer of 5 from these ranges. So the range would become 1, 3, and 4, 6. And like this is the answer. 7 is the answer for 1 to 6. So guys, tell me what is the answer for 7 to 12? How will you calculate? Or like tell me what is the answer without calculating. 13. 13 is not the answer. Guys, see, in 1 to 6, what did we have? 1 to 6, we just had 1, 2, 3, 4, 5, 6. And the answer contained these two numbers. In 7 to 12, what do we have? We have 7, 8, 9, 10, 11, and 12. And the answer would contain, by symmetry, the answer would contain these two numbers. So we would have to add plus 12. Yes, we have to add plus 12 to this initial. Like basically, the number of numbers that we have taken, in all of them, we have to add 6 now. We can't add 6 just one time. That's why the answer is not 13. Like in this case, the answer is 7. And we would just add 2 into 6 because the number of numbers is 2. Got it? Like basically here 6 is added and here also 6 is added. Therefore, we actually have to add 12 to the answer. So the answer is 19, right? So now the problem is solved actually because you can just store two things. Like basically what my problem is that from if I have the answer from L to R, then can I calculate the answer for L plus K, comma R plus K? Like if I just have the answer, so can I calculate for this one? I can't because I need to know the number of elements also. I need to know how many numbers are there in this one. Like in 1 comma 6 there were 2, but in 1 comma 5 there was only 1. So in both cases we added different numbers. So we need to know that like if we want to calculate from this the value of this, then we need to know two things. We need to know the answer and we need to know the number of numbers. Like if we know both of these things for this thing, for this L to R, if we know these, then definitely we can calculate the answer for this interval using this just L to R, right? So what we will do, we'll just store the answer. We'll just store these two things for the intervals that we land. And like what I am saying is for each length, you just need to calculate only once. Like this is basically what I just proved that if we have two intervals of the same length, this is of length 6, this is also of length 6. So if the lengths are same, then essentially the intervals are same. So I just told you that if the lengths are the same, let's say this is length 5, this is length 5. Then if the lengths are same, then definitely we can calculate one from the other. So what I am saying is for each length, for each length, we'll calculate the answer only once. So I just did that. I just stored the answer for 1 to n in DPIM. Like I have this DP, which is a pair. Like for this 1 to n length, I am storing these two things. first the answer, and second the number of numbers in that answer. So I am storing it in dpn, where here n is the length actually. Like for 1 to n, the answer I am showing in dpn. So let's say I want to calculate for, let's say I want to calculate dp of 6. That means I want to calculate the answer for 1 to 6. So first I'll call answer for 3, right? So it will calculate the answer for 1 to 3. Let's say I have that. Now it will try to calculate the answer for 4 to 6. So let's say I have that as well. Like 4 to 6 can be calculated from 1 to 3. And then we'll just use these two answers and just add them to get this answer. Like basically, I'm storing in dpn the answer for 1 to n, right? And let's say you want to transition. Let's say you want to find the answer for L to R. So you can actually get that answer from dp of L, of length. I mean, this is length of R minus L plus 1, right? So you can actually get the answer for this using dp of L. That would just be like, for example, you know the answer to 1 comma 3. Let's say the answer to that is 4 and the number of elements is 2. Like I don't know if it is correct or not, but let's say this is the case. Then to calculate for 4 comma 6, this is same length, right? Actually, let's just take not 4 comma 6. Let's say we take 10 comma 12. So they are same length. So you can calculate this by just doing 4 plus 2 into 10 minus 1 is 9. So the answer for 4 comma 2 would be 22. And also, if we want the number of elements as well, then the number of elements would be the same, right? It would be just 2. Because if we shift 1 comma 3 to 10 comma 12, then the number should be same, right? It is obvious. So that's how you calculate like the same for the same length. If you have one answer, then you can just calculate the another answer. But how will I use this? Let's say I want to calculate the answer for 1 comma n. Then I'll write a recursive function. Ans, like now this is implementation, right? The logic is this only. But let's say how we want to implement. So the implementation goes like, I have this function which returns me the answer. Like it returns a pair. Okay. It returns a pair. Like which is this pair only. It returns this pair for some L comma R. So it takes in L and R, and it returns the pair of L comma R. So if first it checks that if the dp of R minus L plus 1 is not equal to minus 1, like basically if I have calculated for this length already, then I'll just return, like then I'll calculate using that answer. Basically, I have the answer for 1 comma length. Let's say I defined L as R minus L plus 1. Then I can just use the answer from 1 comma L, which is stored in dp of L, and I can just find the answer for L comma R and I'll return it. But let's say we do not have the answer for 1 comma L. We want to calculate it. Then what we can do is we can just break it. We can just recursively call the answer. Like basically, if this dp is equal to minus 1, that means we have not yet calculated the answer for this length. So we'll calculate it. So what we need to do actually is we need to calculate 1 comma L, and to do that we'll call the answer for 1 comma L by 2 and answer for L by 2, L by 2 plus 1 comma L. So I'll call both of these answers, then I'll merge them to find this answer. Then I'll store it in dp of L. I'll store it in dp of L, and then I'll calculate the actual answer. Like the dp of L stores 1 comma L, the answer for 1 comma L. But I need the answer for L comma R, so I'll just shift it using my method. So that's my modus operandi. That first, if the answer for dpl is already available, then I'll use it and calculate the answer for L comma R and return it. But if it is not available, then I'll call the answer function for 1 comma L by 2 to n L by 2 plus L by 2 plus 1 comma L. And then using these two answers, I'll calculate 1 comma L. I'll store it in dp of L, and using that dp, basically I'll do the same thing. Like I'll do what I would have done here. Now I have dp of L. So using that, I'll calculate the answer for L comma R. Don't we need, someone asking, don't we need to store index as well? We don't need to store the index. Actually, I have defined dpn as, I have defined dp of n as the answer from 1 comma n. So like, I'm not storing the answer for every index. I am storing the answer for every length. For every different length, I am storing the answer. And if I want to get the answer for a length, then I just shift this answer. Like if I want to get the answer for 3 to n plus 2, then I can use this dpn and just shift it by 2. So I'm actually not storing for every index. I'm just storing for every length, right? So that's what I did. But now you might ask that if n kilometers are 2e9, then the length, like lengths also can get up to very large. Like the number of different lengths can get very large, right? Like someone may have this doubt. Yes. So actually the thing is that notice that all for calculating the answer for n, we are calling the function for n by 2 and n by 2, right? And then for calculating this n by 2, this would call for n by 4. Then this n by 4 would call n by 8. So as you can see that only these numbers would be called. Like in the DP, only these ones would be stored. This n by 2, n by 4, n by 8, and up to the point it becomes 1. Like let's say n is equal to 100. Then we only need the answers for length equal to 100, 50, 25, 12, 6, 3, and 1. Like it will only call these for these lengths. So basically it is just log n, log. Do you get it, guys? Or should I explain again? dp of n. What are you asking? I can't get your question. Yes, dp of n is the answer for 1 comma n. Yes, that is true. So What state? This is my state, right? Like I'm storing the answer for. Okay, n is up to 1 in n. Actually, I'll just use map, right? I'll use map from int to pair, and this map will only store like log n elements. Okay. So basically, someone asking. So basically, I am getting the answer from 1 till n, and I am shifting the required answer. Yes, for the required answer, you are shifting that, and actually, you have to print the answer for one command only. Like they are asking for one command, you have to print the answer. They have given n and k, and you have to print for one command. So we'll just print dp of n. Right, guys? Got it? Clear? Okay. So I'll just show you the code. One second. So just ignore this one. I actually use it for debugging. This is the actual thing. First, yeah, basically, I'm just outputting the answer for one command. Dot first. Like I'm storing the answer in the first, and in second, I'm storing the number of elements. So I'll just take n comma k and I'll output the answer dot first and new line. And this answer function is like first I'll calculate the length. Then this is for safe measure. Like this was actually when I was debugging my code. Actually, it had some bug, so this is not required actually. Now if L is less than k, then return 0, 0. Yeah. So like if at any point the length of interval is less than k, then she won't observe it. So the answer would be 0 and the number of elements would be 0. Like she won't observe anything. So the answer is 0. Both are 0. Right? Now, if dp dot find L is not equal to dp dot n, like basically for this length, we have the answer. Then we can just shift it. So we'll shift it. Like basically the answer would be this dp L dot first plus L minus 1 into dp L dot second. Because the answer is for 1 comma L and we want from L comma R, like small L comma R. So we shifted by L minus 1. We shifted by L minus 1, right? And second would be just second. Like, the elements won't change, right? So we just return it if we already have the answer. And if we don't have this answer, then we go here. Then we go here, right? So I just call these two. Like if L is odd and L is not equal to 1, like if L is equal to 1, then I'll just store the answer for 1 and return the answer for like L. If the length is 1, then basically the input is L comma L. So my answer would be L and element would be 1. And I just store the dp of length 1 as well, which is 1 comma 1. And basically, if L is not equal to 1, then I'm finding the answer for the left half and for the right half, and then I'm combining them. MP is make pair, yes. So I find the answer for left half, for the right half, and this is the answer for L to R. So that would be just left half plus right half plus um wait a minute. This is L. Yeah, okay. So it would be just first left half plus right half plus the middle element, right? And the number of elements would be just left half plus right half plus this middle element, this is one. The number of elements will increase by one. because we are taking the middle element in case the length is odd. And then we'll store the dp for this length. That is, we have this answer for L to R. So we'll calculate the answer for 1 to capital L by shifting it to the left by L minus 1. So we fill this dp and we just return the answer for L to R. Because this function just returns the answer for L to R, that's what it does, right? And if it is even, if L is even, then we just calculate the answer for left half, for right half, and the answer for L to R would be just the sum of them. And then we just fill the dp for the length L by shifting it to the left L minus 1. And then we return the answer for L to R. Clear? And this will not take off n because we are memorizing it. We are memorizing the lengths. Like only log n different lengths will be called. So the TC of this is log n. All right. Yeah, and just ignore this thing. I was debugging and like I just wrote the brute force approach. This is O of n. And actually I was getting wrong answer. So I just wrote this and debug my this function. You can also see this value. I printed the answer for k equals to 6. And anyways, so yeah, let's move on to the next problem. Wait, why L minus 1? Where L minus 1? Because let's say you have the answer for 1 to n, right? Let's say you have the answer for 1 to 4. You need to find the answer for 7 to 10. So what would you add? Like from 1 to 4, you want to go to 7 to 10. So you would add 6, which is L minus 1. Like from if from 1 to n, you want to go till L comma L plus n minus 1, then you will just add L minus 1, right? Yes. Okay. So let's move on to the next problem. Problem number D. Okay, this one is actually pretty simple. I think for div to D, it is pretty simple. So yeah, let's go ahead. The problem is Chris is given two arrays A and B consisting of an integers. Someone is interested in the largest possible value of P, which is a product of min of AI comma BI after an arbitrary rearrangement of B. Note that she only wants to know the maximum value of P and no actual rearrangement is performed on B. So what they are saying is, let's say we have two arrays AI and BI, then we can rearrange B as we like, and then we'll calculate this value of P, which is the product of AI comma BI, I mean min of AI comma BI from 1 to n, right? Then there will be Q modifications. Each modification can be denoted by two integers O and X. So if O is 1, then Iris will increase AX by 1. Otherwise, she will increase BX by 1. So basically, initially we had two arrays A and B, and there are some queries. In the queries, they are increasing an element of either array A or array B by 1. And we have to find the maximum value of P Q plus 1 times, like before the modifications and after each modification, we need to find the answer. The answer is the maximum value of this this thing, right? The maximum value of this we have to find after each modification. So that's what the problem is. All right. Let's just say our test cases like 112 and 321. So 112, 321. This is A and this is B. So in this case, the optimal approach would be to rearrange B as like A will remain 112 and B will become 123. So the product in this case is um, the min of 1 and 1, which is 1, multiplied with min of 1 and 2, which is 1, into min of 3 and 2, which is 2. So 2. Like this is the answer for these two arrays. So that's why we print 2. Yeah, we print 2. Now the modification. So the number at index 3 is increased by 1. Like for in the array A, the index 3 is increased by 1. So this 2 has become 3, right? So in this case, the optimal value would be like optimum would be to like do this 1 2 3. So in this case, the product would become 1 into 1 into 3, which is 3. So the answer is 3. And then the third element or of the array B is increased. So like this 1 has become 2. So in this for this optimal is to um, sort the array B like this, like 2, 2, and 3. So the answer would become 1 into 1 into 3. So I think you get the problem, like what we have to do. Yes. Okay, so just tell me that for just one array, like let's say the problem was you have been given two arrays and you just need to print the value of P, like the maximum value of P, and you can rearrange the array B as you like. So how would you find the maximum value of P? So can you solve this sub problem? Like basically, there aren't any queries for now. So how would you rearrange the B to get the maximum value? Yeah, actually, this is the tough part of the problem. Like if you get this, then the queries part is actually pretty simple. Like okay, so let's just sort the both and then they manage it. Yes, just sort both essentially. Like we have, so let's say we have an array 2 3 1 4, and this is array A and 5 7 8 6. So we just sort both of them. We sort A, we sort B. So this is 1 2 3 4 and 5 6 7 8, and then the answer would just be the min actually mix 1 into 2 into 3 into 4. So yeah, actually this is correct. I mean this is the answer because but why? Yes, good question. So let's say you have these two arrays. I'll take an example. Let's say you just had these two arrays. Won't there ever be a need to resort the array after some modification? Yes, that's what I'm getting to. Like, and there will be a need, and you can do that. You can do that in like very less time obviously. So I'll just tell you how. I'll tell you how. Just be patient. So I'll just tell why sorting is optimal, right? So tell me, we have these two arrays, each containing n numbers. So basically, we have two n numbers, right? So if I ask you the minimum of these two n numbers, which is 1. So I am saying that 1 would always come in the product, no matter what. No matter the rearrangement, 1 will always come. Yes. So that is one problem because we want to maximize the array. So, but 1 will always come. So with 1, what would you prefer to keep from this array B? You want to maximize. So whatever you keep with 1, that will sacrifice. Like that can't be in the product. So what would you sacrifice? One of the other. Yes. So you will sacrifice 5. So you will pair 5 with 1. Then the second minimum in this whole thing is 2. So definitely 2 would come. So with 2, what would you pair? With 2, you would pair 6. So this is sorting. This is the same as sorting. You take the minimum of both the arrays, remove them, then second minimum of both the arrays, and third minimum, and so on. Like, got it? Like, got the intuition? Cool. All four of you got the intuition? Yes, okay. So if this was a problem, then it would be like I think B or C, or maybe it won't be asked in your div 2 because it is not so interesting. But the problem here is that we have to change. There are some queries. There are Q queries, right? So let's say we have this array and we sort it, right? Or let's do the samples. We have this sample one. Someone is asking first and minimum elements of both the arrays combined. Sorry, what are you asking? I can't get you. I'll just explain, and then if you have a doubt, then you can ask. So let's say we have these arrays 1, 4, 2, 7, 3, 5, 1, 4, 2, 7, 3, 5, and then we have 7, 6, 5, 6, 3, 3, 7, 6, 5, 6, 3, 3. So what we'll do is we'll sort them, but we'll sort them keeping in mind that like what is their initial position in the array. Like basically before sorting, we'll just give a pair. Like we'll just keep like 1 comma 0, 4 comma 1, 2 comma 2. Like we'll store it in a pair so that we know that for each element what was its initial position. Because we need to update that. So we have to store it as well somewhere. So we'll just store it as a pair and then we'll sort it. Alright. So after sorting it becomes like um it becomes 1, 2, 3, 4, 5, 7, right? 1, 2, 3, 4, 5, 7. And sorting B, that results in 3, 3, 6, 6, 5, 7. So now you can easily calculate the answer by multiplying these minimums, right? But now let's say you have a query. You have this query, let's say 2 comma 5, which means that in the second array, in the B array, we need to increase this value to 4, the fifth index to 4. So this 3 will become 4. So I'll change this 3 to 4. And then you will just like calculate the new answer. And actually you don't need O of n to calculate the new answer because you can just change this index. Like basically you can divide by the previous minimum and multiply them by the new minimum. Like previously it was 2 comma 3, right? So previously the minimum was 2. So you will undo that, you will divide by 2, and then you will multiply by the minimum of these two numbers, which is still 2. So the answer won't change. The answer didn't change actually. It is still 840 and 840, right? But my point is that you can do that. You don't have to take O of n in this. You can just change this answer in O of 1. You will just change the index. You just change that index by dividing and then multiplying. But then the problem would happen. What if we need to resort? Like let's say second one is 1 comma 6. So we have to change 6. So it becomes 6. This is fine. Then we have 1 comma 5. So 3 becomes 4 and this 3 becomes 4. This is still fine. Then we have 1 comma 5. So this 4 becomes 5 and this 4 becomes 5. Now this is a problem because now we need to resort. But we can just do that, right? We can just find the first element which is greater than 5. Like initially there was 4 here and we need to increase this 4 by 1. So by binary search, we'll just use binary search on this array because it is sorted. So we'll just do binary search and find the last 4. We'll find the last 4 which is there in this array and we'll just swap these two. Like we'll make that 4 a 5 and like that's it. I mean, basically what I'm doing is, let's say I want to increase. Let's say I have 1 1 2 2 2 3 4, and let's say I want to increase an element which is 2. Let's say I want to increase this. Then what I'll do is I'll just find the last 2 using upper bound of 2. I can just do upper bound of 2 and the previous. I can do upper bound of 2 for previous. So I'll get this element and I'll increase this one. So it will become 3. So that's why it remains sorted as well. It remains sorted always. And then I'll just update this element. I'll update this in the product. But the thing is, there is one like there is one problem in this. That how will we know that which element is like we have sorted, right? We had sorted this array, but the queries are in the original array. Like they are giving indices in the original array, and we have to like increase that particular value. Like let's say it says that increase the index 2 or increase the index 3. Then here we would have to increase this one. But how will you know that? How will we know that where is this 2? For that we can just store. Like after we sort, then we can just store that for each element where it is in the array. In the array, where is it? Exactly. So technically what we are doing is we'll make a new array. Like if you guys have heard of this inverse permutation, like there's a permutation and then something is called inverse permutation, which just stores that, let's say I have this permutation 0, 3, 1, 2. So the inverse of it would be just the position array. Like this index would store that where is 0. 0 is at 0 position. Then this would store that where is 1. So it is at 2 position. Then this would store whether 2, it is at third position, and this would store where is 3. So it is at 1 position. So this new permutation, this is called inverse permutation. And like a similar idea can be applied here. Like what I am just doing is I am storing that where is each element. Like after sorting, what let's say I have this input, I have this array A as 2, 7, 5, and 8. So when I sort this, first I'll make a pair of this. Like I'll store this as 2, 0, 7 comma 1, 5 comma 2, and 8 comma 3. Then I'll sort this. So it would become 2, 5, 7, 8. So it is like 2 comma 0, 5 comma 2, 7 comma 1, and 8 comma 3. So basically, I have this new array A, which is sorted. And corresponding to this one, I'll make another array, which is A inverse, or let's say AP, which is the position array of A. Actually, I had called it AI in my code, basically A inverse, which stores that where are the elements. So it would store that like 0, 1, 2, 3. So 0, where is 0? It is at 0. Where is 1? It is at 2. Then where is 2? It is at 1. And where is 3? It is at 3. So that's what this AI would store. So let's say we have a query that we want to modify the second element. We want to increase the second element. Then we would just check that um, second वाला कहाँ पे है? Like from this array, we just check that second one is at that's first position. So in this sorted array, we need to increase the first position. So we'll increase 5 to 6, right? So that's what we will do. But problem तब आएगी when we need to resort. Like let's say we had this array. We had this array A as 5 comma 0, 6 comma 3, 6 comma 2, and 7 comma 3. So this is sorted. And the inverse would we just store, we will just store the inverse, which is 0. Sorry, my bad. It's not, the 3 is repeated. It's 1. So 1 is at 3, 0, 1, 2, 3. So 0 is at 0, 1 is at 3, 2 is at um, 2, and 3 is at 1, the positions. So when the query asks me that the third position, like the query is like 1, 3, or let's say 1, 4, because it's one indexed. So if the query comes at 1, 4, then it is asking me to increase third element. It is asking me to increase third element, and we know it at 1. So this element we need to increase. So we'll increase it by 1. But then we have to resort it. So what we'll do is we'll just swap it with the last 6. Like in this array, it is sorted. So we'll just find the last 6 and we'll swap it with that. So let's say we had many 6s. Let's say we had like something like 5, 6, 6, 6, and 7. And the indices let's say just random 3, 1, 2, 4, 0. So we had this, and the inverse array would be something like 0, 1, 2, 3, 4. The inverse would be 0 is at 4, 1 is at 1, 2 is at 2, 3 is at 0, and 4 is at 3. So let's say the query comes like 1 comma 2. So 2 means 1, like because the input is in one index and we are using 0 index. So 2 means 1. So it is asking to increase this element, which is at position 1. So it is asking to increase this 6 to 7. So to do that, we will just swap. We will just swap. We'll find the last 6 in this array, and we will just swap these two elements. So it would become 5 3 6 4 6 2 6 1 and 7 0, and then we would increase this 6 to 7. And then, but the thing is that we would have to update the inverse array because these numbers have changed. Like this 4 has come here and 1 has gone here. So we just need to update the position of 4 and the position of 1 in our inverse array. So we would have to make just two changes in the inverse array, and that's how, like, it would be done in O of 1 time. Like for finding the, like, the last 6, we would use O of log n to find the last 6. Then to swap, we would use O of 1, and then you just update the inverse array in O of 1, and then we'll update the answer. Like we'll divide by the initial and multiply the final to in O of 1. Or actually, for dividing, we need O of log mod because modular inverse. So log mod. So M. So yeah, this is per query, the time complexity. So the final complexity is O of Q into log n plus log mod. And for the pre-computation, it takes O of like n log n time because of sorting. So yeah, for like a brief overview, that whenever we are increasing an element, we just need to swap it by this and this, and basically the positions would get changed by that. Like the position of 4 and 1 would get swapped. So we would have to update that in the inverse array. Like, is it somewhat clear? What about the rest of the people? Is Gupta, is it clear? Yeah. Okay. So I'll just show you the code. And yeah, actually I use this struct to find the answer modulo m. Like it is very convenient that instead of writing int, you can just write mint, and automatically it will take the mod for you. So like I have this answer, and I'll just multiply, like basically here I'm multiplying it by the minimum. So I don't need to take mod, it will automatically take mod. Like it is a struct. So it just takes mod automatically. So yeah, what I'm doing is taking the input nm, then answer is 1. The input I'm taking in pair. Like the array is pair. So a dot first I'm taking the input and a dot second is I. And same for b. Then I sort both of them and I calculate the initial answer by taking min of ai dot first from b dot first. Right. Then I have the inverse array ai and bi. And to fill these, it is like this. Like the position of ai dot second is I. That's how I fill the inverse array. This is standard. Like in permutations, it is very standard that if you want to find the inverse array, then you can do it like this. That the position of a dot second is I. So all of the positions will be filled if you iterate over 1 to n. Right? Then I just print the answer before the queries, and then I'll handle the query. So I'll take the O and X, and decrease the X because of indexing. Then if O is 1, then I update the AI. And yeah, X is equal to AI of X. What this does is, like, I hope it is, I think it's clear, but like, suppose we have this inverse array, and the problem wanted me to decrease or increase the first index, then essentially I want to increase third index, this one, because I have sorted it. So in the sorted array, where is my element? That's what I am finding. So that's what, like, this initially x was in the original array, and doing this changes the x in the sorted array. Now I just need to increment that. So I am finding the last occurrence of that element. Like I am finding the upper bound of ax dot first and comma infinity, because that will cause an up. Like I had the pair, right? This array A is an array of pairs. So I have to find, like I have to do upper bound with the pair. So I just put in infinity. So this will give me the last index, which is the same value. And then if it is equal to positive, like my positive is the last index, like in this case, um, I have to update this. So my x is 2, x is 1, sorry. And my positive is this 3. I mean, 0, 1, 2, 3. Yeah. So, but yeah, if x is equal to positive, then that means that there is just one 6. So I don't need to swap. So I just increase it. I just increase it to 7. So first I'll divide it by the min, by the answer by min. Then I'll increase it. Then I'll multiply the answer by min, and then I'll print the answer and continue. But if x is not equal to positive, that means I need to swap. So I just I'll just swap. And actually I took, like, I divided both the indices. Like basically what I did was I'm swapping this and this. So I just divided the initial answer by this. Like I did answer divided by 6 and answer divided by 6. And then after swapping, I just did answer multiplied by 6 and answer multiplied by 7. Like I mean not 6 and 7, minimum with B as well. Like, I just did both of them because I was thinking maybe both of them can change, but only this one changes. So I just had to do pos 2, not necessary to do x as well, but I just did it for the safer side. So I just divided the answer by x and also pos 2. Then I swapped x and pos 2. Then I increased the thing at pos 2 and I updated the x and pos 2. Like because they have changed. So in the inverse array, I just updated the positions. So a of ai of, like, position of pos dot second is pos 2 and position of x dot second is x. And the final, like, initial was, like, initially I, yeah, initial was this, and finally it became this. Like after incrementing, I found the final value, and I did answer equals answer divided by initial into final. Like, I hope it makes sense. And then for O equals to 2, I just did the same thing for B. I just copy pasted this whole code here, and I just replaced A with B, right? And yeah, so is it clear or does anyone have doubt? Clear. Okay, thanks. Can you show that mint? Yeah, so it is a struct. Like if you have learned some like, oops, then basically this, like, overloads the operators. It overloads all the operators. So you can just use this struct as an int. You can copy this from my code. I'll just send the link in the YouTube video. Actually, this takes a bit more time. So like if the TL is borderline, like if suppose you have 10 power 8 operations, then you shouldn't use this because it is very slower than normal taking the mod. Okay. Now on to problem E. All right. The problem E goes like there is a tree consisting of n vertices. Let a caterpillar denoted by an integer pair p comma q. Its head is at vertex p. Its tail is at vertex q. And it dominates all the vertices on the simple path from p to q. Like it is there from all the paths from the path from p to q, right? And the caterpillar sequence of p to q is defined as sequence consisting only of the vertices on the simple path sorted in the ascending order of distribution p. Like basically, if you have a tree, um, let's say you have this tree, and let's say this is my p, this is my q. Then I have a snail or a caterpillar. Sorry, I have a caterpillar which lies on these nodes. All right, and this sequence of this, and these nodes, this sequence, they are calling it caterpillar sequence. Okay. Now Nora and Aaron are taking turns moving the caterpillar, with Nora going first. Both players will be using their optimal strategy. Okay, like this, it is a game. It is like a game. They will play to make himself or herself win. However, if it is impossible, they will play to prevent the other person from winning. Like they will try for a tie. Like basically, if winning is not possible, then they will try for a tie. Okay. In Nora's turn, she must choose a vertex U adjacent to P, which is not dominated by the caterpillar, and move all the vertices in it by one edge towards the vertex U. Like basically, um, she will just pick one edge. Like let's say you have a tree like this. Okay, and the caterpillar is lying somewhere around here. This is the caterpillar, and this is end P. This is end Q. Then in her move, Nora can what? Nora can do what? Nora can actually uh, like hold this caterpillar from its head and pull it either here or here. But she cannot push it. Like she cannot make it so that P goes here. This can't happen. She can only pull the caterpillar towards either this node or this node. Okay. So in Nora's move, she can do this in one move. All right. And in Aaron's move, he can pull the caterpillar to the other side. Like suppose Q is here. So Aaron can pull the caterpillar from its tail to the this node. Okay. So this is what Aaron can move. Nice. Whenever P is a leaf, Nora wins. And whenever Q is a leaf, Aaron wins. If either initially both P and Q are leaves, or after infinite turns, the game has not ended, it is a tie. Like basically, the game will go on. And if after 10 to the power 100, but essentially infinite, after infinite turns, if the game has not ended, it is a tie. And it is a tie if initially the snake or the caterpillar is at leaves, like both are leaves. So basically, the aim of the game is to, like, for Nora will try to bring the caterpillar to a leaf, and Aaron will try to do it as well. And whoever does it wins the game. Like essentially, Aaron has to ensure that the node Q is a leaf, and Nora has to try that node P is a leaf. So that's the game. Now the problem is, please count the number of integer pairs P and Q such that caterpillar is initially at PQ. Aaron wins the game. Like we don't have to tell who wins. We have to um, what we have to do is we have to count the number of PQ in which Aaron wins. Okay. So I hope the problem is clear. Yes, okay. So basically in this, of course, we have to think that when would Aaron win, and when would Nora win, and when would be a tie. So guys, actually, like let's say we have a tree initially, and there is a caterpillar. Like you have to visualize actually. You have to visualize this. Um, the caterpillar is lying, let's say here. So no, this is P, let's say, and this is Q. So Nora would try to bring it to a leaf. So definitely what Nora would do is that she will pull it towards this node, and then she would win the game, right? But let's say this was not a leaf. If there was another node here, then this is not a leaf, right? So what would Nora do? Nora would pull it either here or here. So let's say she pulls it here. So the snake would look like this, and the caterpillar, whatever. The caterpillar looks like this. Now the blue one, right? Now Aaron has to pull. So Aaron will try to pull it again here. So it will the caterpillar will come again to its initial position. So they will like keep pulling. The caterpillar won't be able to go anywhere. This will go on until infinity, right? Like they will play 10 to the power 100 games or moves and no one will win. So definitely the game would be a tie in this case, right? So what I am saying is that after one move, if Nora doesn't win, then Nora can't win. Like if Nora has to win, she will win after one move. Because if she doesn't win after one move, then Aaron can just undo that move. Like whatever Nora did, let's say we have this tree, and the snake, where is it? Let's say this is like this, and the snake is here. Snake is here, or not here. Here. Uh, the snake is, let's say it is, let's say the tree is like this, and the snake is here. Okay, so definitely wherever Nora moves, okay, like this is P, this is Q. So definitely wherever Nora moves, like she can either move it here or here, here, here. She cannot win, right? But then wherever she moves, Aaron will just undo that move. So definitely Nora cannot win in that case. Like if Nora has to win, she has to win in the first move itself. And then same for Aaron actually. Like let's say Nora moves this caterpillar, then Aaron has to move that caterpillar somewhere else. And if he doesn't win, then he can also never win. That's the thing. Like maybe you can imagine as well, because basically Aaron would try to pull it towards the nearest leaf, but Nora also pull it. Like if Aaron doesn't win immediately, then Aaron can't win ever. Same for both of them. Like is it clear or should I explain more? Clear. Okay, so we want to like count the number of pairs P comma Q such that Aaron wins. Yes, Aaron should be in a node next to a leaf. that is actually not sufficient. Uh, Aaron should be, yeah, like on his move, he should be a node next, should be on a node next to his, next to a leaf, so that he can just move the snake there. So we want, but actually the starting player is Nora. Like Nora moves first actually. I think it is written there. Nora going first. So since Nora was first, it becomes a bit complicated. So we want to find when does Aaron win. Okay. So either Aaron will win in the initial the starting only. Like if the Q is leaf, if Q is leaf and P is non-leaf, then Aaron wins before any moves are done. That's the rule, right? And if he doesn't win, then he has to win in the next move. Like once Nora will move, and then Aaron will move, and he has to win in this move, right? So if he wants to win in this move, definitely what we can say that before this move, the Aaron has to be beside a leaf. Like after Nora's move, in this case, like here, Q has to be beside a leaf, the node Q, right? Do you agree? Yes. So, for the sake of convenience, let's just call those nodes as type 2. Like, I call the leaves as type 1 and adjacent to leaves, adjacent to leaves as type 2. My, okay. So, what I'm saying is to win, like for Aaron to win, either P is equal to P is not equal to type 1 and not equal to type 2 as well. And Q should be equal to type 1. Like type 1 is leaf, right? So if P is type 1, then definitely Aaron won't win because either Nora will win or if both are leaves, then it will be a tie. So P can't be type 1 and oh, okay, wait. P can be type 2 actually. Like, sorry. P can be type 2. Basically, either this should happen, P is not equal to type 1 and P equal to type 1, or or like this is basically the starting of the game. In the starting, if Aaron wins, then this should be the condition. And in the second one, like after two moves, after one move each, if Aaron wants to win, then what should be? Let's think about it. Like after Nora's move, after Nora's move, you should be able to type 2. Do you agree? Yeah, I think you agree, right? So therefore, if I ask you where would Q be? Like after Nora's move, where would Q be? Like initially, if the snake is somewhere, let's say the snake is, let's say this is a tree, and the snake is here. Let's say this is a tree, and the snake is here. This is P, this is Q. So after Nora's move, definitely can I say that since this is Q, The next node in that path, that is this node, this will become Q after Nora's move. When Nora does a move, definitely this node will become Q, right? Yes. And we want this node to be type 2. Do you get that? Like after Nora's move, this snake will move like here, and this will move from here. So this node will become the new Q. And we want this node to be type 2 so that after, like now it is Aaron's turn. So Aaron can move it to a leaf. So we want this new Q dash, that is the next node on the path to Q, to be of type 2. All right. But also we want that P should not be type 2. Because if it is type 2, then Nora will just move once and she will win before Aaron gets a chance. So let's just call this new node Q dash. Like we have the two endpoints as Q and P. Let's just call this next node as Q dash. So our condition is that um, our condition, like either P is not equal to T1 and Q equals to T1, or P is not equal to T1 and T2, and Q dash is equal to T2. Right, guys? So this is the condition. So either one of these we have to solve. Like either this should be true or this should be true. So we'll just find out the number of pairs for this case and for this case, and we'll take the union. But in the union, the thing is that maybe some intersection is there. Maybe some common cases might be in these two. So let's think about it. What common cases are there, right? So this one says, okay, let's just write it here. This one says P is not equal to T1 and Q is equal to T1. This is one condition. And another condition is that P is not equal to T1, T2 and Q dash equal to T2. This is the second condition. So is there any overlap between these? Like is there any value of P comma Q which happens in both of these? Like essentially this is saying that P is not a leaf and Q is a leaf. This is saying that Q is adjacent to a leaf. I mean, sorry, the next one to Q is type 2, and this one is not a leaf and not type 2. So, guys, actually, in this, the common portion is that when P is type 2 and Q is a leaf, which is type 1, then what you can see that this is satisfied in this case, and also this is satisfied because Q dash is just the next node. So the next node is definitely type 2 because Q is a leaf. So Q dash is adjacent to a leaf. So it is type 2 and P is also type 2. Uh, P is not equal to type. Wait. Sorry, P not equal to type 2. My bad. P not equal to type 2. Just a minute, guys. Yeah, so in this case, like this case happens in both of them. What I'm saying is, um, if P is not type 2 and type 1 and Q is type 1, like Q is a leaf. If Q is a leaf and P is not problematic, then we are counting them in both. Like in this one also we are counting, and in this one also we are counting because like basically we have a node which is not adjacent to a leaf and not a leaf. This is a tree. Yeah, so this is a tree. Now let's say Q is this. Our snake is here. This is P. This is Q. So definitely this is the case where Aaron wins before any move is played. So ideally this case should be included in just this one, right? So it is included in this one. But also the thing is that we are counting it in this one also because the next one to Q, this is Q dash. It is on type 2, and also the P. P is not on type 1 or type 2. So basically what we are counting this case twice. So therefore we need to subtract it in the end. Okay. I hope it is clear. Like so. Anyways, let's just count for type 1 and type. Like let's just count for these two conditions. One condition is P is not equal to type 1 and Q is equal to type 1. So I think this is easy. Like you just need to count the number of P comma Q pairs where P is not a leaf and Q is a leaf. So that's just number of non-leaves. Number of non-leaves into number of leaves, right? So this is the type. This is the condition one, that P is type 1 and Q is equal to Q. Sorry, P is not type 1 and Q is type 1. So like P can take all the non-leaves and Q can take all the leaves. So this is the condition. This is the number of ways of the first one, right? The number of number of P comma Q pairs. And for the second one, it is a bit tricky. Like we want this to be of type 2 and P should not be of type 1 and type 2. So what we can do is to count the number of PQ pairs like this. We want to count the number of P comma Q pairs such that the next node to Q is of type 2 and P is not of type 1 and type 2 both. So actually we have to do it often. We can do it in often. How? Like what I am doing is I am fixing Q dash. Right? I am iterating over all the possible Q dash numbers. Like let's say I have a tree. I have this tree and the leaves are here, right? These are the leaves and type 2 are these. The type 2 are the ones that I'm circling in red. Sorry, not this one. This, 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 and this, right? So all of these nodes could act as Q dash. So what we can do is we can just iterate over all of these nodes and count the number of P comma Q pairs that we get from each node. Like let's say that if this node acts as Q dash, then what is the number of ways? Okay. So how do we calculate that? So basically, let's say we want, let's say we fix a node. This is a node, and we have some subtrees surrounding this node. and we have this subtree. So basically, if we want to check that if this is q dash, then how many p comma q pairs are there? We want to check this. So how will you count that? Basically, what we need to do is we need to ensure that this q dash one comes on the path from p to q, right? And we want to ensure that this is the next, like this is beside q dash. This is like q, then q dash, then some nodes, and then p. The path should be like this. So essentially, what we want is the different components that this q dash has. We can just select two of those. Like, let's say I choose p from this component and q from this component, then definitely I can say that q dash will lie in the path, right? But also I want that q should be adjacent to it. So q can be this only. Like if I'm choosing q from here and p from here, I only have one choice for q. I can choose only this. And for p, I have all of these choices such that they are not of type 1 and type 2. Like this is the condition, na? That p is not of type 1 and type 2 and q dash is type 2. So we are iterating over the q dash, all of the q dashes. Let's say we have fixed one q dash. Then for this q dash, we want to count the number of pq. So if I decide that I want to pick p from this subtree and q from this subtree, then for q I have only one option. Then I have to pick this because q dash is the next element to q. And for p, I have the options that I need to select such that p is not equal to type 1 and not equal to type 2 as well. So in this subtree, actually there are no ones like these are type 1 and this is type 2, right? So actually there are no way to choose p from this subtree. But there is some, let's say I decide that I need to choose p and q from here, like just a minute. Let's say I want to choose p from here and q from here. So definitely I would have to choose q as this, the node adjacent to this q dash. And I could choose p as this one or this one because they are not of type 1 and type 2. This is type 2, this is type 1. But these two nodes I can pick. So in general, if I say that there is some node which I want as q dash, and there are some like blocks, there are some subtrees, then basically, let's say there are like what we care about is the number of nodes which are not of type 1 and not of type 2. Like here, these two nodes are neither of type 1 nor of type 2. So therefore, we would count that in our answer. So what we just need is the number of non-type 1 and non-type 2 elements, non nodes in all of these. Like let's say this subtree has n1, this subtree has n2, this subtree has n3, and this has n4 number of non-type 1 and non-type 2. Is not type 1 and it is not type 2. So let's say, so basically all the in all the different ways, I want to count the number of like ways. Basically, I can I have four subtrees. I can choose p from anyone and q from anyone, and I would have to iterate over all the like combinations to get my answer. But that is too slow because there are total NC2 combinations. So this wouldn't work. So we actually have to calculate. Like, let's say I choose these two. So my answer would be Like for these two, my answer would be N2. Do you agree to this? If I have to choose P from here and Q from here, then the number of ways to choose P is just N2 because there are N2 number of nodes which are not of type 1 and not of type 2. And for Q, I have to choose the one which is here. I have to choose this node only. I have only one option. So therefore, from these two, I have N2. Then let's say I choose Q from here. Then also I have N2. Then if I choose Q from here, then also I have N2. Right? So if P is here, then Q can be either here, here, or here. So in all of these cases, it is N2. Then let's say P is here. Then I can choose Q from here, here, or here. And in all those cases, the answer would be N1, the number of pairs. So plus N1, plus N1, and plus N1. So the similar, like you can observe that all of the n's are coming, like this is 4, so they're coming 3 times. So the answer is just 3 into n1 plus n2 plus n3 plus n4. Like this r q dash is connected to 4 components. So the answer is 3 into the sum of those, like the sum of the number of non-type 1 and non-type 2 nodes. So is this clear? Like how I got to this? Yes. Okay. So actually, as you can see that when I'm fixing Q dash, the answer is like this is 4. So therefore, 3 came here. Like the degree of this Q dash is 4. So 3 came here. But if the degree of this Q dash was some D, then it would just be D minus 1. D minus 1 into the summation of N. Summation of N. And do you agree that, like, let's say in the whole tree, in my whole tree, there are total n, or let's say, yeah, there are total n nodes which are not of type 1 and not of type 2. And I know that this q dash is of type 2. So definitely I can say that like this sum is n, isn't it? Like I have this whole tree. In the whole tree, I know that there are n nodes which are not of type 1 and not of type 2. So what I can say is that the sum is just n, because this q dash is not included in that n, right? Because this q dash is of type 2. So I can say that the sum of this n1, n2, n3 up to n4 is just equal to n. The total number of non-type 1, type 2 nodes in this, right? So we have the answer. Like we can just iterate over all the type 2 nodes and check that if they are q dash, then how many pq would we get? So we would get n into degree minus 1 number of pqs. So we just add it into answer. Answer plus equals this, right? But the problem here is that we have like one case we had that q is type 1 and p is not equal to type 1. This is one case that we had already considered. And then another case that we had was that um, this P is not equal to type 1, type 2, and Q dash equals to type 2. So basically, we calculated the answer for these two cases and we added them. But we also need to subtract the common portion in them. So the common portion is just that those like that case when P, like in that case where Q is a leaf, Q is type 1. Like since Q is type 1, it is counted in this one, right? Because if Q is type 1, then definitely Q is type 2. Like if you have Q as a leaf, then of course the next element would be next to a leaf. So this is type 2. So if Q is a leaf and P is not equal to like type 1 and type 2, then we are counting this case in both of these. So we will subtract, and we can just subtract like the number of leaves into the number of non-type 1 type 2, which is n. This is n, and this is the number of leaves. Let's say L. So we just subtract n into L from the answer, and this is the answer. The rating would be like I think 2000 easily, I guess. So I'll just show you the code. Yeah, so actually I had done something else earlier, so this is not required, but my code still contains it. So I'll just remove this from my code and will send the new submission link. But right now I'll just explain using this code. So I have this array called marked, and marked means type 1 and type 2. Like if a node is type 1 or type 2, I'm marking it. Okay. So initially it is true, and then I just assign it to false. Like if I is a leaf, then mark of I is false, and the adjacent to it, which are type 2, they are also false. So basically, mark contains then all the nodes which are not type 1 or type 2. Okay. Then C is the number of nodes which are not type 1, type 2. Then this ignore this thing. Okay. Then we have adjacent to a leaf, that is type 2. This stores type 2. And this is the count of type 2. So what I'm doing is I'm iterating like for a leaf, um, n minus c minus. Yeah, so like I am initializing this vector, uh, type 2 vector. So for all leaves, if it is a leaf, then all of the adjacent elements, actually there will be only one element adjacent to it, which is adjacent of I comma 0. So I am setting that to true, and I'm incrementing the count. But I think there is a mistake here, um, because it might be that the same vertex would be counted two times. Like in this case, this is a leaf, and this is a leaf. So this is counted two times, or I mean three times. So there is something, but somehow it works because I actually, I mean, in this for loop, I'm adding the second thing. Like the second condition, like P is not type 1 and type 2 and Q is type 2. So in this, I'm iterating over type 2, and this is degree minus 1 into the number of non-type 1 type 2 nodes. Like actually C is the number of non-type 1 type 2 nodes, and this is actually always false because, and this code is actually very confusing because I wrote it in a hurry. So actually, I'll just send a cleaner code. This is very hard to explain. I'll send a cleaner code. You will find the link in the description of the YouTube video. So let's just leave it for now. Like if you have a doubt in that code, you can ask it in the comments or in the doubt section. The logic is clear, I think. Yeah. All right. So thank you for attending, guys. That's it for today. Goodbye. Goodbye, 2024.